Okay, class, listen up. Forces in uniform circular motion. So we finished up centripetal acceleration. Now we just got to tag an M into everything and call it circular motion, centripetal force. Okay, we got to throw mass into it, just like Newton's second law. Force is mass times acceleration. So if we throw mass into centripetal acceleration, we've got centripetal force. And we got three equations. Equations. Oh, let's make it color coded here.
On EDU, does the document have answer or no?
Yep. It might be slightly different because it's from a previous year.
No.
Like the examples might be different, but it's the same.
Okay.
Sorry, what's the difference between centripetal and centrifugal?
Good question.
What is
Until you finish writing these out, then I'll answer that.
We're just adding it. She's going to reflect the
And there's no derivation for these. It's just Newton's second law applied to centripetal acceleration. Those are the same three equations that we saw with centripetal acceleration. But if we throw an m in there, mass term, for F equals ma, and we've got centripetal force. Now again, I hesitate to put the vector brackets on there, or the vector notation on there, because this is just the magnitude. Just like centripetal acceleration, the direction of the centripetal force is always towards center of the circle. Yeah.
What for the second equation? What's the small f, smaller case f?
Frequency.
Frequency.
Yeah. In hertz.
Hertz.
Yeah. Number of cycles per second. Yeah.
So if we have a one more answer, don't get direction.
Yeah. If it doesn't ask for the magnitude, if you want to be careful, then always say towards center of circle. Yeah. Okay, so why is this centripetal force and not centrifugal force? Really good question. Centrifugal force is the apparent force that is seemingly being experienced from the point of view of the person or the observer experiencing centripetal force, experiencing circular motion. If you're in a car, okay, and you didn't know that you were turning, let's say, okay, you're in a car and all the windows are blacked out and you can't see outside and you go around a sharp corner. You wouldn't know you're going around a sharp corner. All you would know is you would feel, if I was turning that way, you'd feel like you're being pushed outwards. Okay? That outward force is the apparent force, is the apparent centrifugal force, but that's only for a person in that reference frame. That's actually moving in that non-inertial reference frame, okay, because it's a changing velocity. So it's this apparent feeling of being pushed outward, but really what's happening from the point of view of someone outside the reference frame is the side of the car is actually applying an inward force to keep you moving in that circular path. Okay, it's not that you're being pushed outwards into the car, it's that the car is being pushed inwards into you, just like when we were walking in a circle outside and I had Dimitri pushing Josh. Okay? It's that car is doing the same thing. It's pushing you to move you in that circular path. Okay, and that's the real force. That's a centripetal force. Yeah.
What if your car was to fish?
If your car was to fishtail, same thing. You just feel the opposite of the centripetal force. You feel what's that centrifugal force from the point of view of the person inside the moving frame of reference.
And we base that off the idea that since the acceleration is happening towards the inside of the circle, then
That's right.
the force that you're feeling is pushing you away.
That's right.
Yeah.
Yeah.
And you're not applying the force that pushing you.
Well, by third law you are, but you're not. The force is not pushing you outwards. The force is the car pushing you inwards towards the middle of the turn. Okay, the force isn't you falling outwards.
Oh,
Okay.
okay.
Okay, example number 1. Yeah. Yeah, again, inside your frame of reference, you're not moving. You're not accelerating inside your car. You're not moving side to side, up or down, hopefully. So the centrifugal force is equal to the centripetal force inside the frame of reference only. From outside, we'll never include the centrifugal force. Okay, it's always the net force has to be directed towards the middle of the circle, 100% of the time. 1,200 kilogram car moving around a circular track of radius 240 meters with velocity 45 meters per second. What's the minimum coefficient of friction between the tires and the ground in order to enable the centripetal acceleration? Is this coefficient static or kinetic? Ooh, we're going back to friction.
So guys, what's 45 squared?
Do that
It's
kinetic.
a large number.
8,000 plus 5.
That's 2025.
Isn't it
25.
But the answer is 10,125, right?
I don't need this.
Look at the ants.
Think I can do that in my head?
No, I haven't calculated.
Yeah, it's on point.
Time mass.
How is it?
Oh, sorry.
10,125,
Never
right?
mind. I just found the,
10,125. Is it?
I found, yeah, 10,125.
Times
It's not the friction.
2,025. Wait, what? Sorry. Oh yeah. 10,125.
Oh, 240.
Actually, it's only 10,000. Is it?
We'll leave it as 3, just for the
Oh,
sake of
okay.
it. Actually, yeah, we'll
It's
leave
only
it.
10,000.
You're right.
Put that as Newton.
You're right. You're right. We should be true to significant figures. So what we should do is 1.0 times 10 to the 4 newtons. Okay, in order to show that we have two significant figures. Thanks, Molly.
And it's moving at a constant velocity, not accelerating.
Well, it is accelerating because it's moving in a circular
All
path.
the other costs.
Its speed isn't changing though. It's constant speed, but because its direction is constantly changing, that's acceleration.
But it's constant.
So does the
That's
force?
right. What's that?
So does the force change? Even though it's going.
Does the force change? No, the force is the direction of the force changes.
But the force stays constant.
That's right.
Even though the car is turning.
Yeah.
That's cool.
Accelerate around the circle instead of going at constant speed.
Well, there should be more advanced math behind because then your speed will be increasing as the force is increasing. Yeah. There should be probably linearly increasing force. Depends on. It's the same as if you're doing non-uniform acceleration. There's no like 5 equations. It's all based on whatever the motion is.
I bet there's a question that's going to be like calculate the force.
All right. So we've got the force. Now, what is supplying that force? What's actually keeping the car on the road?
Friction?
Friction between the tires and the road. And even though the tires are moving, this is a misconception. Everybody wants to say it's a kinetic friction because the tires are moving, but it's actually a constant static friction. It's a continually forming and releasing static friction. Okay, the tires aren't sliding on the track. Okay, if the tires were sliding, unless you're skidding out. If the tires were sliding, then you'd have a kinetic friction. But whenever your tires are working properly and they're gripping the road, that's actually static friction.
Wait, so anytime. What do you ship that? Wait, so the car then, will it have the same friction coefficient from whether it's like at a standstill to when it's moving then? If that's
That's right.
the case?
That's right. Okay. So we're going to say that the centripetal force is being supplied by the static friction. So now we can make an equation out of that.
We're saying that FC is equal to Fn as well.
No. Fn is equal to Fg, the force of gravity acting on the car. Maybe because the car it's not on a bank curve yet. We haven't gotten there yet. For now, it's just on a level track, so normal force is the force of gravity.
What's the question?
And the weight is 1,200 kilograms.
This is the coefficient of static friction.
Wrong, right?
So we got 10,000 divided by 12,000.
Bro, that's just work.
0.8333. So 0.83.
Quickly, Rob, what's the unit on coefficient of static friction? On coefficient of static friction. Trick question, there is no unit on the coefficient of static friction.
It's a coefficient.
It's a coefficient.
That says the friction is 83% of the normal force.
It's not saying anything counts as a right answer.
True. Yeah, there you go.
Well,
He said,
nice.
No, no, test. No, just
Alright, so we got to throw some friction in there. That was good. We got some centripetal
See how
force,
happy
some
you are
friction.
right now.
Yeah. Right. Oh, this is the good stuff now. Okay, I'll give you a second to get
You
the
like NASCAR?
Okay. Another 30 seconds to make sure you got caught up.
If we know to calculate that, right?
It's not hard calculation.
This is good once YouTube of this physics.
Yeah, once you
teacher.
know it, it's actually.
It's hilarious.
Physics teacher.
There's a video on YouTube of this physics teacher singing to his class about physics. Like about
Do it.
I promise I won't
I
say.
do it.
I don't think we.
No, we don't.
Oh, and then upload it to your YouTube channel.
They should have a instead of grad.
No, watch. One day, Mr. Kingersky is gonna like sing to himself randomly, and it's gonna have like the most beautiful voice, and then we're just gonna like.
I'll tell you right now that that's not going to happen. Okay, here's where the question gets a little challenging. Now we're making this a frictionless road. Okay, we've got nothing to keep the car from... Okay, so...
The car won't start though, will it?
Listen. Okay, it's got friction along the path that the car is moving, but it doesn't have any friction side to side.
Nice try.
Okay.
Nice try.
We're trying to make an imaginary world here, but it has to be like that or else the question doesn't work. So now the question is, what's the minimum banked curve that'll keep the car actually on the road? And this is a tricky one. So it's a free body diagram at first here.
How could
no,
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 it could be.
3D body diagrams, you have to be.
UFO with wheels.
That's coming at you. Okay, this is coming out of the page at you.
It looks like an alien. Wait, why are we drawing another one when it's right there?
Because I want to make some other notes on it. Okay, forget about components of force. Okay? Forget about the components of the parallel force down the ramp or whatever. What are the only two forces? If this thing is coming at us, and it shows right there, what are the only two forces that we care about in terms of the free body diagram? Yeah, what's that one? Normal force and
Force of gravity.
force of gravity. Now, problem. How can we, how can we possibly get f net equals 0 in this case?
One of the sideways ones.
Oh.
Yeah, we couldn't. Well, actually, you couldn't get f net equals 0 because they're the only two forces.
Yeah.
All right, because we're always going to have some sort of angled component on Fn that can't be counteracted by Fg. So, but that's good, okay? Here's what we want. When we add these two vectors together, remember we want this car to follow centripetal acceleration, which is always angled into the middle. Now, this is not a real force. I'm just showing that this is where we want F net.
I mean the car is sliding down though?
No, we want F net to be horizontal with its, how can I say this? It's not angled down the ramp, it's angled directly horizontally inwards to the middle of the circle. Okay, so this is a big circular, here's the middle of the circle. This is a big circular path that goes into and out of the board. Okay, we want it to follow the circular path constantly.
But the car isn't like that. The car should be.
No, that's
No,
fine.
yeah, because we're like cutting.
Yeah, because we're cutting it.
Yeah, I tried to make this facing the car face. It's a terrible diagram. So that car is. That's why I said the motion is coming out of the page. Okay, that's the vector for out of the page.
It's coming out of the page.
Now,
Yeah, you guys.
addition of forces. So here's what we get when we add the forces up in their vector values. In this case, and only in this case, where you have centripetal acceleration, is the normal force ever going to be greater than the force of gravity? Okay, the normal force in this case takes on the hypotenuse of the vector triangle. It's kind of weird. Because the addition of those two forces has to create the net force that we're looking for. Okay, the addition of the normal force and the force of gravity has to create an overall centripetal force.
You always try to find the triangle.
Actually,
That's right.
so
Yeah,
it
yeah.
always has to be a right angle.
Yes, in this case, yeah. In every case, because you're making a circle, like it.
Because you're making a circle, so you use a car.
Yeah.
Awesome! Awesome logic.
No, because the net force. It depends where the middle of the circle is, I guess. Maybe if it was like a weird wonky circle, like kind of like a.
Oval.
No, not even like an oval. I can't think of a case when it wouldn't be. When it wouldn't be a right angle triangle.
Well, that's good.
Okay. So now we can actually. Now we can actually do the math behind this, okay? So now we can calculate what the centripetal force has to be. Oh, we did that in the last question, okay? From last question.
So we know what that is.
0.8.
No, yeah, sir.
Wait, no. It's actually the force.
It's 1.0
not actually the
times
coefficient.
negative 4.
Yeah.
So
Oh,
that's
sorry, 10 to the 4.
so that's 10,000.
Oh, how you get the triangle? Just like
Yeah.
this.
Oh.
So, you know that when something's going around in a circle,
Yeah.
it's always pointing to the inside, right?
It's all
So what we do is make it point back to the
So just-
Well, the diagram isn't to scale.
tail, it's a tail, right?
Yeah, but they're all going in the Wait, you need to do.
Yeah, you gotta.
Trigonometry.
No, because
Yes.
no, because you're saying FC is going in that direction.
Wait, we know FG, right?
So it's just going the same thing here.
So it's the square root.
What's that?
of-
We know FG.
Yes.
We know FG, we know two parts of the triangle, so we're good. We can figure out Fn and the angle.
I'm getting it. I'm understanding. I understand.
So that's psi.
Okay, say that again.
Psi inverse.
Yep.
Wait, how many?
Psi inverse.
We always wanted it like
Psi inverse.
I'm sorry, I don't understand.
No.
How can we, oh, it's only negative. We only assign negatives if we're dealing in one direction. Like, if we're dealing with forwards and backwards, up, down, that's when we assign something negative. In 2 dimensions, it's just the result of the vector addition.
So it's 56 degrees then?
Oh, you're a step ahead of me here, Tom. Hold on.
Oh, Josh? Is it 56?
Nick has my using so I don't know.
It's like sine inverse.
Wait, are we using CAD?
Oh, actually, no. It's 10. Or, my bad. 30, 40.
Hold on.
Solving for CAD, yeah.
40.
What is 40?
What angle are you
40
guys
degree,
talking
is it?
about?
The question is asking for the angle.
Yeah, the question is asking for the angle.
Yeah, it's gonna be a different angle though. Yeah, it's gonna be.
Oh, it's going to be different.
But why are
So
we
it's just
using
gonna
that
be-
angle? I thought we were using the angle of the car.
What?
Got it.
Yeah, we want. Hold on.
G times cos theta equals Fn, right?
We want
We
this
know the
here.
angle of Fn and the
We're getting the
vertical,
angle,
right?
And we want
What angle
that
of
as
C?
C. FN is C.
Yeah, we want this angle. That's gonna be equal. Yeah, that's right. My bad.
What? The question said.
No,
The diagram on the question is confusing.
Wait,
What? Look at the graph. It's like the
No,
diagram.
Because the angle is just a back angle. We want a different angle.
Angle of
Look
the
at these
ramp.
two thetas somehow equal each other.
Look at.
No, I know,
Look
but
at the picture.
it's the angle of the ramp. And
Wow.
The car and the ground. Is I don't know.
Wow.
Yeah.
Yeah, they're alternate angles of each other.
50.
50? Great.
Wow. Yep, that's a scumbag question.
It's also amazing to me. I don't get why.
Like, how is the picture and the question different?
Because just we want this angle here, the angle, the banked angle, okay? Then by
I want to just.
I thought it's.
hold on.
Okay, that equals that.
Yep. Let's just get all the angles. So let them all.
Hold on, now I'm confused. This.
No.
Yeah, exactly. Look at the picture.
So that's FCU discussion and
Hold on,
FQ
hold
would be
on,
up, right?
Hold on. This picture here. This is theta.
Yes.
It's the opposite.
Why is that there?
Like you drew a line like that below. Oops.
Theta.
Is that supposed to be theta? Well, because look at the triangle. It's actually going down anyway.
So this is theta as well. Yeah, this is theta.
Yeah.
So the opposite angle.
Yeah. So no, we did solve for the wrong one.
Exactly. It was the original one. Right?
It was the original one.
Exactly. Like why don't people?
You're getting really worked up, Tom. Okay.
Wait,
My bad.
okay, let's think this through and then say the answer.
No, I'm 100% sure this time.
So it's 40.
I was right.
Yeah.
Oh! Why did we want to do this to me?
I was right. I knew it was.
So, why is it 40? Oh, it's 1 over.
Because it's 10 1 over 1.2. Or 10,000 over 12,000.
I don't understand.
40.
Where'd you get it done?
This is theta, so this is theta up here.
Wait, but it's also.
Because this is 90 minus theta, so this is.
Okay, 40.
Wait, it's also this theta right here, right?
No,
One
because
right
if you
there.
look
Yeah.
at the triangle,
Yeah,
it's
that's that. That's that.
The
Normal
force
force
is
is normal force is 90 degrees to it.
FG is
All
always down.
all of the angles look like sort of like just find the force.
No, that's not true.
The normal
Because the red,
force.
It's 90 degrees to.
No, they're all the same.
It's 90 degrees to the angle of
Should be all the
inclination.
Because we're calculating.
The
Ours
normal
should be on the
force,
same angle. Oh, that
Oh, we
Yeah.
got calculated it wrong.
which is that normal force here. So we're solving
It
for.
should be the same. It looks like
Well, the car wants they want the angle of the car
Well, how about this
normal?
This data is actually right here.
You mean horizontal?
That's only for.
Is that dotted line?
Okay, that doesn't-
It is,
No,
that's
no, no.
vertical.
Well, it's the same. Well, look at this.
That's not for
this.
centripetal force. That equation.
Or this
The
and
fact
this.
that
It's
normal
the same.
force, the
It's more
hypotenuse
degrees,
is
because if you look at
completely
this,
different
Yeah.
analysis.
That's still
Okay?
and then the ramp is 50.
Yeah.
How else are we supposed to show
I'm good. People trick me for like something.
Okay, guys, that was great.
So I was right.
I started off
And
on
people thought I was wrong.
So remember, the net
What was
force
that person?
is okay. What I want you to take away from this, no matter what scenario they throw this at you, it could be a plane doing a banked curve, whatever. It's all the same thing. The net force is always to the middle of the curve. They're always to the middle of the circle that's being drawn. Okay, all your vectors that are being any and all of the vectors that are actually in your free body diagram have to add up to the centripetal force, which is the going towards the middle of the curve. Okay, so it's not going to look like you have a net zero force on your free body diagram when you draw these, and that's okay.
So rather than adding up to 0, they add up to the centripetal force.
That's right.
Because they can't be zero. Obviously, they can't be zero.
But you can't put 50%.
Yeah, those two pro.
I can actually do that. No, that's actually level 1 trick. So.
Oh, I can do that. I can't.
Yeah, it's
Yeah.
just.
I can't get it to come
We
back.
said
No, and
that,
then you pull it.
we said the fact that the force of the body are cannot equal F net. That would mean that
Cannot equal F net.
can equal zero. That would, well, if it can't equal zero,
That's right.
right, that means it's not a constant velocity.
That's right, because its speed is, or its direction is changing.
But then, this is centripetal force only with constant velocity.
Constant speed. But not only with constant speed, but that's our analysis. We're doing this like that's as far as we go. Is with
Oh, yeah,
constant
what
speed.
do you
It's accelerating around it. If you start, like if you're going around at that
Yeah,
pace and you're speeding up.
Adam already asked that. It's just it just gets more complicated in terms of math.
And then it lands like.
Yeah. Okay, guys, here we go. So every question we've done so far has been horizontal circular motion. When we go into the vertical plane, now we have to throw gravity into the mix, so it gets a little trickier. When you're spinning something around in a circle, a picture's worth 1,000 words. Give me a second here.
Are you guys actually scared?
Because that's flying towards my face. It's
I
quite
remember back
scary.
in grade 8 when my science teacher brought in a massive slab hammer, or whatever it's called.
Slap hammer.
Slap has
Slab hammer. What's it called? Like a
Sledgehammer?
no, it's not a sledgehammer. It was
hammer.
brought in a
a
sledgehammer.
lumber. It was like a lumber or something.
What are you saying? I don't know.
He brought in a really big hammer, and he smashed it on the table whenever he wanted somebody's attention. Yo, no, it was made of stone.
The judge's hammer?
It's made of stone.
Mallet? Sorry.
Base?
Mallet, like order?
No, it wasn't made of wood. It was made out of stone.
Mallet. Brought in fake.
Well, baby's made by wood.
Face all
Yeah,
Shut up. This is a joke. Shut up!
At least one.
You guys laughing at my joke anyway.
I didn't laugh or something like that. So what's ever.
So the centrifugal force is always less than it was before at full tension, right? It's always.
What?
So you know how like at the top of the circular path when the tension is 0,
Yeah.
it's always like the centripetal force,
Yeah.
that force supplied by the gravity is always less than the force carried inward when the stroke is at.
Okay, I want you to rethink what your question is. Take 30 seconds. Just rethink your question and re-ask it. Okay?
Reword it.
It's hard.
Think about
Only
it.
at the top.
That's right. That would be this is for minimum velocity, or for minimum. For minimum.
Is that 30 seconds?
Maybe you can't ask the same question.
No. What do you call the force? What do you call the force again? With the force? With the it's centripetal force, but it's their specific name. With the full tension.
Again, full tension. I don't know what you mean by full tension.
Oh, you mean like zero?
Yeah, what's actually like spinning?
You mean when it's...
What's not at minimum?
When it's okay, so when the velocity is above minimum,
Yes.
there is tension in the rope
Yes.
At the top.
at the top.
Yes.
Yeah.
So that's nice.
So.
So that.
Oh, so then you're asking what the net force would be, or what the centripetal force would be?
No, I'm asking like that force will always be greater than the.
No, the combination of Fg plus the tension, there'd be another arrow going down that's tension. That would equal Fc. Okay, the centripetal force would then be supplied by tension and the force of gravity.
Inverted.
So it is less when the tension is zero.
What is less? You understand what I'm saying?
Yeah.
Come on, let me tell you something. Okay, this was some of the best advice that anybody has ever given me ever, and it was given me in university by a TA, that teacher assistant that could barely speak English, and it was pretty funny. Because we were doing the same thing. I was doing the exact same thing. I was struggling through asking a question, okay, and I felt like an idiot. And the teacher said, "Listen, most of your answers will come to you if you simplify your question. If you figure out exactly what you want to ask using the proper terminology, most of the answer will be in just figuring out your question." And that it seemed like such a common sense thing, but it stuck with me for my whole life. I don't take a lot of just stupid advice on face value, but it makes a lot of sense. A lot of just by figuring out what you're actually asking, that can actually answer your question a lot of the time. Okay, keep that in mind. That's good. Write that down. Okay, so if Fg equals Fc, then Mg equals Mac, so AC equals G. Yeah. Yeah.
What is that called?
The tension is equal to the
We're gonna do that next.
Yeah, but then.
No, the tension is not equal to the force of gravity. The tension plus the force of gravity is going to be the centripetal force at the bottom. It's going to be greater. You'll see. That's what the next question's about.
Can I just say top and
We didn't
bottom?
even answer question A.
Can you say what?
Top and
What
bottom.
are the maximum tension?
Is that it? Minimum tension is that the
What
top?
is the maximum?
Yeah, we
tension?
already answered minimum tension at the top. But we got to deal with the maximum tension at the bottom.
What is the maximum? Does the rotation have a maximum speed?
No. It just at any given speed. What's
Oh.
going to be the maximum and
Oh.
minimum tensions of the rope?
Or like because this velocity keeps increasing, the rope will the tension of the rope will increase until the rope breaks.
Yeah.
Right? Right?
Yeah.
Yes.
So good.
You still
It's like a
wrong.
focus, right?
Good work.
Is it not 2 C's, 2 R's? 1 R?
The question there is right there.
It's 1 hour.
Operators.
Occurs.
Oh, good, I wrote 1 hour.
Big 2
don't think there's a word in the English language with 2 R's and R's.
Roar.
Roar?
No, in a row.
I'm gonna go find out.
True, irresistible.
Irresponsible.
Correlation.
Irresponsible.
Correlation. Correlation.
Oh, you're
I'm not sure about correlation. I mean,
Coupon.
the prefix is co, so.
Mr. Kingersey, do you say coupon or coupon?
Coupon.
Coupon.
This is cute.
Who's a coupon?
I say cute.
Yeah, it's
Coupon.
No.
Coupon.
My whole family says
Okay, can we
Coupon.
focus on this? I'm still recording the damn lesson.
Irrefutable. Irrigation.
Wait, so wait, why are we
Irresponsible.
We already said that one.
Okay, so the question is, why is there now a greater tension than there is the force of gravity? And the reason is because it's still rotating. So our net force is not going to be 0. Our net force has to be the centripetal force. So what's that?
So the final tension number is the tension of the string minus
Why we're adding the vector arrows?
We didn't do it yet.
Oh, gravity.
No, you did.
Right?
That's the only vector that's
Zero.
Oh, it means you're.
Oh, the arrows are, no, you're right. Okay.
No, we're just doing the
So it doesn't matter.
Yeah,
It doesn't matter. I just wasn't labeling it before. It's just because I wasn't labeling it. They are vectors.
It's literally a fine epic.
What is the symbol for tension? Not
T.
tension.
Capital T.
Not tension, period.
Period, capital T.
Wait a minute.
You just have to know.
Ask me what the symbol is for temperature. Capital T.
Everything else you want to just
Or capital.
No.
time
There
is
might be a couple
small
more.
t, right?
Yeah, time is small t.
Because at first I was like, okay, so if you have a vector over t, that's one thing, and then if you have it without, that's
Yeah, you
another
can draw a vector. I just haven't been doing it. I want to stay.
Yeah, because vector just
Look, see this whole note. I haven't been doing the
Right, that's
vectors.
correct.
I know.
So, but they are vectors.
it's there. It's valid.
Yeah.
It's always supposed to.
So Kingersey, this is vector for temperature too, up and down.
No.
So here.
If it's temperature go left and right, left and right.
Temperature was
Bum.
32 degrees. I need to remember.
It's right here. Period. It's time.
Stop that. Mike, literally Mike. Hey, Michael.
Yeah, he erased it because.
So, Mike,
No, we're not factoring in on that.
Yeah, no.
Cycle.
Oh, it's T plus.
The acceleration.
Oh. Which is always the less. It's the least tension.
Yeah.
Wait, but doesn't T equal FG?
No.
No.
Oh, right, because of it's the vector.
Depends on the
It's doing this thing.
Yeah.
length of the string. That's all.
So it's
Oh,
right. It's due to the acceleration then.
Okay.
no, it's probably revolving because it's looking around.
Wait, so
Rotating is. That's the other way around.
Guys,
Minus.
throw. Hey. FG is going to be negative. We call it positive. Okay.
I was right.
So the tension is the sum of FG and FC. So at the top, we can have a zero tension. Okay, at the very top of the rotation, we can have zero tension in the rope, and that's fine because that's the slowest possible velocity at the speed that the object can be rotating at, as long as the centripetal force is provided by gravity. And then at the bottom, the tension is always going to be greater than the force of gravity, because it's going to be the sum of force of gravity and the overall centripetal force. Any questions?
So to figure out what C is for that, we have to just put it into the
MV squared over. Yeah.
Yeah. M squared over R.
Yeah.
Can we still back one second?
Yes.
That's not a good note, anyways. I like that last page.
We already went over centrifugal force.
Yeah. Well, we're gonna jot it down there at the bottom. Yeah.
What is centrifugal force?
I'm gonna write it down for you. Yeah.
The
Makes
first
you
time I
circular
learned about
momentum. Yeah, but not.
centrifugal force,
It would be instantaneous velocity. It would be like based on the object's velocity. It's like we don't do angular, like angular. In high school, you'll do inverse.
no, like,
Yeah.
what my
If you're
one
taking
guy did is he got a pail of water, right?
Which I am.
And he put like
Or I'm not.
some money in it for me, and he was like, all I need you to do is like get the
I'm
money
not taking-
from the pail, right?
I'm actually taking
And put it in a bucket, and then he
Okay, guys.
started to swirl, and the money was
Write this
in the
down,
bucket.
please.
I'm gonna speak to centrifugal force.
You can do it at the bottom of your page. You have half a page there that you probably won't have any writing on.
Right? Sorry? Centrifugal. No, but this is centrifugal.
It is, yeah, that is.
Centrifugal would be the force pushing the money up into the bucket.
What?
Because
Money?
It was my granddad. He was the person who teach me about centrifugal force.
I always did the water in a bucket out of it.
Yeah, but then the water handle broke.
Yeah, then it would break and fly
See,
everywhere.
that's why my granddad did money in the bucket.
Actually, what is it in there?
She didn't get money at the end, did you?
What is centrifugal?
Yeah, my dad probably taught me, but
He's
like,
like,
I couldn't
"I don't
translate
know."
it.
It's a good equation.
If you're driving a car, are you
Money in
observing?
this bucket.
If one falls, you can have.
Are you observing the forces if you're driving a car?
It's more of an uncle thing, no?
It is.
Wait till I'm an uncle.
I'm the victim.
Uncle and shit.
I still have cousins that call me that, but it's not the same.
Your cousin has like Uncle and shit.
Because one of my cousins, I have a baby cousin, he's in Amsterdam.
So you're
Yeah, he calls me uncle, but I'm not.
Oh, he's gonna have fun.
Because neither of my brother and sister have
Oh,
have
yep,
kids.
learned
What
it.
about your cousin?
Learned it.
Kids? My cousin has kids.
Yeah, yeah, exactly. So I was like, my cousins'
Well,
kids call me
I
uncle.
not really expected
Centrifugal force.
Yeah, that's all you understand.
That's the thing, so.
Well, centrifugal force.
Hopefully, in
Usually,
15 years when my brother has a kid, you should go come in.
it means that X is the center force.
Lesions exist.
And I'll be like my uncle,
Or
the
D.
guy who'd always
C
pay
is
for
hard.
pizza
So
Hut.
it's the center.
He was
N is
engineer.
force. It's just force.
Sorry?
Or power. Yeah.
But one of my uncles, he, what's it
Like how
called?
you yeah, like how you pronounce
He
India.
was free pizza when he was there. And he's just such a good cook. Like, it's unfair. Like he just spends all day like making pizza. He's so much of a better cook, but they won't give him a job because he's that much.
Did you guys write this down? Almost. Write it down.
One of my uncles.
Oh, I got it.
is a really, really good
I
cook.
know what it is.
But the best job you can
I,
get.
I knew what it was, but I couldn't connect the Mandarin with the
No, but
English.
he falls asleep on the job.
Man, I learned so much ago.
That's the thing.
I
Like,
just couldn't-
he needs to.
I learned biochem
to keep him
today.
awake.
Yeah, I'm
I
saying
learned-
now.
Can I just drop it?
Okay, that's about it for today.
You're feeling good today.